Hi everyone, thank you very much for joining me to this first lecture of Econometrics 2A. So actually this is a continuation from where you stopped with my colleague Bonolo, and we will be starting with chapter 8, which concerns sampling method. So what are the different methods for sampling and the central limit theorem. But before I start the lecture, I would like to tell you guys that I've uploaded all the material that you need, except this video that I'm recording here, which will actually explain the slide that you have on your Blackboard under Unit 8. So I'm asking you to go on Blackboard, log in. So on the go under Unit 6, you will see all the material. So I've posted this slide that I will be taking through. I will be taking you through. And I posted all the required material that we will be using in this chapter. So guys, go there. And one thing is also I've posted a video that is explaining how you can download from Google and install a software called Minitab, which is one of the software that we'll be using in this lecture, beside Excel that you know and you master very well. So thank you guys. Just go on Blackboard and we get all the material, and then we can be on the same line with this slide that I'm explaining to you. So quickly, as I said, this chapter concerns sampling method in the central limit theorem. So what is the goal of this chapter? This chapter will be explaining to you why we sample the population. So why the population are sampled. Secondly, we'll describe the different methods that exist to sample a population. So actually here we have 4 different methods that can be used in order to sample a population. We will also define and construct what we call a sampling distribution of the sample mean. So I will come back to this point and we will deeply go through and we will explain what do we mean by sampling distribution of the sample mean. After this objective, the third one, so the fourth one will be that we will try to explain to you what is the central limit theorem and how can the central limit theorem be applied in order to find probability of selecting possible sample mean from a specified population. So these are the 5 key goals of this chapter, and you will go through the book and you will get more explanation on the goals of this chapter as I'm enumerating them here in this slide. So quickly, let's see the first goal. Why do we sample the population? Why sampling the population? So this question is answered in the way that we sample the population because there is a physical impossibility of checking all the items in the population. So consider you want to understand what is the distribution of income in South Africa, and you decide to go and collect earning information to each and every single person or each and every single household in South Africa. So you will find yourself that there will be an impossibility, a physical impossibility to do so, to get those information on earnings of household or individual in South Africa. So one way to avoid that physical impossibility is to go through a way of sampling. So you can say, okay, South Africa is 55 million, but let me take 10% of 55 million. So, and I can only have something about like in average, 500,000 to give a questionnaire and get the information that I'm looking for. So the second reason why we sample the population is that it is very costly to studying all the items in the population. So studying all the items, getting information for each and every single individual in South Africa will cost you a lot of financial mean. And quite often, you don't have the money that is required to go and find each and every single person in South Africa. So one of the ways also to avoid these difficulties when we are trying to get information from the population is to go through the way of sampling. So the third one is that it has been shown that quite often sample results are usually adequate. They are usually correct. So because we know that from a sample we can get information that are reflecting the true information in the population, so we can only use samples in order to get the information that we are looking for, that specific population. So the fourth reason of why we sample the population, that contacting the whole population will be time consuming. So it can even take you 2, 3, 5 years just to get information on the average income in South Africa. So because of that difficulty also, we are requested to go through the way of sampling. And finally, there is a destructive nature of certain tests. So guys, these are the 5 reasons that can be put on the table to justify why we need to sample the population in order to get the information about that particular population. So this being said like this, so we can now move to a very interesting point that explains how sampling is done in practice. So here we are saying that in practice we use a notion of probability sampling to construct a representative sample. So what is a probability sampling? A probability sampling is just a sampling approach in which larger populations are selected using a method based on the theory of probability. So if you want to construct a sample on the entire population of South Africa, so you can select the individuals. Let's say you want to have 5,000. You can select all of those 5,000 using the notion of, or the theory of probability. So this theory of probability is simply saying that for a participant to be considered as a probability sample, that person must be selected randomly. That's what it means, this theory of probability. So if someone has to be part of your sample, you need to select that person randomly. Okay? So the random selection, for instance, is done like that. If you have a box where there is names of 50%, so you just close your eyes and you just pick one name and you open and you read the name, and that name will be the first person that will be part of your sample. So that is what it means to select someone randomly. So when this notion is applied, so then we can say that our sample has been constructed in a way that each and every single person could get a chance of being selected. So that is what we are saying here, that the most important requirement of probability sampling is that everyone in your population must have an equal chance of being selected. Let me explain this by giving an example. So consider, like in the case where you have a population of 50 individuals. So when you apply the notion of probability and you want to select 10 people from the 50, so you need to do it randomly. But for you to do it randomly, you must use the theory of probability, where each and every single person must have an equal chance of being selected. Now, if you have a population of 50 people and you want to select 10, so we can first calculate the probability that every single person has to be selected, to be part of the 10 people that will be selected. And one way of doing it, which is the unique way, is just to divide one person divided by 50. And if you divide 1 divided by 50, you will get a ratio of 0.2. So you can multiply this by 100 and you will get 2%. So in this case, we can say that each and every single person has 2% chance of being selected in the sample of 10 individuals. So that is how we can use a probability sampling approach in order to make sure that our sample will not be biased. So this is very important to know. Now let us move to the different method of probability sampling. So what is the method of probability sampling? So There is four key and four different methods of probability sampling. So the first method is what we call the simple random sampling. So the simple random sampling is simply an approach where a sample is formulated so that each single individual in the population has the same chance of being selected. But let me recall a bit the notion of the difference between a population and a sample. Maybe some people, they don't understand what is a population and what can be called sample. So a population is the entire group of individuals or subjects under consideration. So if you have an entire group of individual or subject under study, under consideration, that one can be called a population. But a sample, in the contrary, a sample is a part or a subset or a subgroup of that population, that entire group of population. So if you take a subset of that entire group of population, that one is called a sample. So to come back to what I was saying, a simple random sampling approach or method is a method where each and every item or person in the population has the same chance of being included. And I have explained this in the slide that we just finished. So we will illustrate soon how we can do a simple random sampling in Excel. If we have a given population and we are asked to draw from that population a given number, which is our sample, how can we do it using simple random sampling? Now the second method is called the systematic random sampling. One thing, before I speak about the systematic random sampling, one thing that you need to know, we quite often use a simple random sampling in a case where you have a population which is numbered in a given order. For example, you have a population of 50 individuals. So you have individual 1, individual 2, individual 3, 4, up to 50. So if you have such kind of population that is ordered in a given number, so the best method to use is a simple random sampling. And to your information, I just want to tell you that this is the widely used method of sampling. So if someone asks you what is a widely used method of sampling, you just need to tell him that it's a simple random sampling. So be careful here. So secondly, now let me talk about the systematic random sampling. This method is quite applied where your population, the information containing in your population is not ordered in a given number. Is not numbered in a given order. Sorry. So once you have such kind of population, the best approach to go is to use a systematic random sampling instead of simple random sampling. So let me explain to you using this example. So if you go on Blackboard, you have this document, Word document, which is named class example for sample mean. So, and take the second example. So here this example is telling you that suppose a cell division of Computer Graphic Inc. need to quickly estimate the mean dollar revenue per cell during the past month. It found that 2,000 cell invoices were recorded, okay, and they stored in the file drawers and decided to select 100 invoices to estimate the mean dollar revenue. So actually what they are saying here, you have a population of 2,000 cell invoices and they need to estimate the mean revenue, okay, the mean dollar revenue per cell during the past months. And they decided to construct a sample of 100 invoices. Okay, so simple random sampling require numbering of each invoice. This one I've explained it to you before using the random number table to select 100 invoices. So I will also, when we will be doing the practical soon day, I will explain what does it mean to construct to use the random number table. What does it mean? So here, what we are saying that in order to apply the simple random sampling, you need to have this 2000 invoice ordered. But quite often you will find that these 2000 invoices, they are not ordered. And the numbering process will be a very time-consuming task. So if you want to number these 2000 or by their number, say, okay, this is invoice 1, 2, 3, 4, it may take you time. So one of the approaches that have been suggested is that instead we can use a systematic random sampling in order to get the 100 invoice we need, and we can now understand what is the mean or the average dollar revenue per sale during the past months of this company. So to go back to our slide, so how do you do it practically? So actually practically there is two different things. The first thing is that by doing the systematic random sampling, if I can again repeat what the method is about, is that the item or individual of the population are arranged in some order. Okay, so this some order is simply mean that they are not in an order that can start from 1, 2, 3, 4. No, they are in different, like numbering. They are numbered in different way. So you can find invoice 1, invoice 200, 500, and so on. So a random starting point is selected, and then every KF member of the population is selected for the sample. So I was saying there is two different things that you need to do if you want to use a systematic random sampling in this case. Remember, we use this method because our population is not ordered, as we should get it in a case where we may apply a simple random sampling. So the first things to do if you have such kind of data is that you will determine what we call the KF member of the population. And this KF member of the population is simply a ratio between the population size and the sample size. So remember in our example here, the population size is 2000 cell and the sample size is 100 invoice or cell invoice. So for you to construct the KF member of the population, you will take 2000, you divide it by 100. And if you do so, that's what you have here, you will have 20. So actually your KF member will be 20. Now what you will do, you will go now in that population of 2000 and you close your eyes and you select randomly one number. Let's say that number is 50. Okay, so that 50 will be the starting number. So that 50 will be the first item or the first invoice that will be will be forming the 100 invoice that we need in order to understand the average income. Now we will have 50, and after 50 you will count 20 invoice after 50, and that one will be the second invoice that will be part of your sample. So you have actually 50. 50 after 20 you will have 70. 70 after 20 you will have 90. 90 after 20 you will have 110, and so on. That is how you will construct your systematic random sample using these two different elements. The first is to determine this ratio of the KF member of the population by taking the ratio between population size and sample size, and then now you will start adding to a random number that you will choose by closing your eyes. You add this 20th number. I think it is clear. So one thing that has to be noted here is that if you choose randomly the number 50, okay, so to add the 20th number, you can go in each and every direction. So you can go in the left, or you can go on your right. Okay, it doesn't mean that you will only go on your right and you construct those numbers, those invoices that will be part of the 100 you need. So that is how you use the systematic random sampling, which is quite different with the sample random sampling. So now the following method is a method that is applied when a population can be clearly divided into groups based on some characteristic of the population. So if you have a population that can be divided into groups, okay, and those groups, they are divided because of some specific characteristics of the population. In that scenario, in that case, we use what we call the stratified random sampling. So actually, stratified random sampling is an approach where a population is first divided into subgroups, and those subgroups are called strata. Okay, and a sample now will be selected from each stratum. So a stratum, if I can explain the difference between these two terms, a strata and a stratum. So a strata refers to a single group of category or category of the population. That is what we can refer to as a strata. So a stratum, not a strata, sorry, a stratum refer to a single group or category of the population. Let's consider that we want to investigate on the average earning, okay, of the population based on gender. So you see, gender is one of the characteristics of the population in South Africa, and we want to investigate on the average income or the average earning based on gender of the population based on gender. So in this case, okay, your stratum will be male or female, okay, and your strata will be the gender. That is the group of the population, so it will be gender. So do you understand? So that is how you can differentiate these two terms. And a stratified random sampling is that a population can be divided into subgroup called strata, okay, and a sample is selected from each stratum. So actually, here is a strata. The strata in this example of average earning or income of the population, the strata will be the gender issue, but male and female, because the male is a group of the population and the female is another group of the population. So your strata in this case will be male and female, but your stratum, okay, is only one, okay, one group, which will be male. I think I make things clear here. So that is how you can do in order to construct your sample using this method, the stratified random sampling. So another common type of sampling is what we know as a cluster sampling. So this method, the cluster sampling, is often applied to reduce the cost of sampling a population scattered over a larger geographic area. So consider we want to know the average income in South Africa. Okay, but we know that South Africa is very large and is divided into provinces. Sorry, South Africa is divided into districts. You have a part of South Africa that is urban and the other is rural. So to construct such kind of sample, it will become very complicated. So one of the ways is to use a cluster sampling, where you can say, okay, your first unit of sampling will be, let's say, province. And now you said, instead of going everywhere in province, Gauteng province, I will only choose the district of Gauteng, if there are 7, and I will say, okay, in this 7 districts, I will not go also in those 7 districts. I will only take some urban areas, some towns, and some villages. Okay, and once you do such kind of exercise in order to construct your sample, and get the information. So you are actually clustering your sample, your population, in order to get a clustered sample. So in terms of the definition, so the cluster sampling is an approach where a population is first divided into primary units of sampling. That's what I've said. And you can say, okay, the primary unit of sampling here in this case will be province, and the secondary unit will be district, and the third unit of sampling will be some town in the district and some villages. So then now you will go in following that kind of subdividing your population into this unit of sampling. So that's what I was saying, that in this approach a population is first divided into primary unit, then samples are selected or collected from the primary unit. So in this case, that is how you will do. So you say, okay, the primary unit of sampling in this case actually will be those villages and those specific town, and now you can collect your sample based on that approach. So let me say a few things and then we'll go to the practicals and see how we can apply some method in Excel in order to construct our samples. So one important thing to be noted here is that if you decide to apply a non-probability sample, so inclusion in the sample is based on the judgment of the person. So what we are saying here, remember I said for your sample to don't be biased, you need to apply the probability sampling notion, where each and every person will be selected randomly, and each and every person will have the same probability, an equal probability of being selected. But if you decide to use a non-probability approach, sampling, so to be part of the sample will only depend on the judgment. And this kind of approach quite often lead to bias because you want to know, for instance, the average, the mean income of the population, and you are staying in an area where you have friends. So what you will do where you are using this approach is just to go to those friends and you collect the information. But one thing is that you are more likely to get people that you are including in your sample that have similar characteristics. And once you have only people who have similar characteristics, you will find yourself that your sample is not representative. It's not representing all the characteristics that you will be having if your sample was constructed using probability sampling, where individual will be selected randomly. So this is very important to be noted here, and shows actually the importance of constructing your sample using the notion of probability sampling. So, and one thing, and this is the last things of this first video before we go to the practical, is that you have some errors when you do sampling. So the sampling error is actually the difference between a sample statistics and its corresponding population parameter. So that is what we call a sampling error. So suppose you have a population, okay, and you have some information, prior information of that population. And let's say that you are investigating on the average mean in South Africa. And you know from the previous information that the average mean is estimated around 5,000 rand. Okay? And now you decide to collect a sample from the population of South Africa. You collect a sample and you estimate the mean based on the sample information. So let's say that, okay, you find that the mean income from the sample is 4,998. So you see that there you have a difference of 2 rand. So that difference of 2 rand is what we call the sampling error. Actually, that difference is a downward error from the information that we know about the true average income in South Africa based on the information of the entire population. So we will also explain this practically and how you can do it practically in order to calculate what we call the sampling error. So before we move to this second part of the video that we call sampling distribution of the sample mean, let's go to Excel and try to see some example on how we can do sampling based on simple random sampling. Actually, in Excel we will show these two different methods. The simple we will show these two different methods, the simple random sampling as well as the stratified random sampling. Let me quickly go through the Excel file. So here's the Excel file. You just go on Blackboard and you open the Excel file. So and you will get a file that contains this information. So if you go in your Excel file, you will find a file that contains this information. I think everybody can be able to see clearly. Cool. Now you can also take your Word document and you will see example 1. So actually what we are doing here is that we are given a population of 100 individuals, okay, for the country called Gondwana. So consider a population of 100 individuals for the country called Gondwana, and we are interested to know the average mean, okay, or the average income. We are interested to know the average income. You can correct on your Word document the average income of the country's population, and we decide to sample 25 individuals, okay, which form 25% of the population. So through the simple random sampling method, determine the individual to be part of the sample of 25 individuals. So that is the question that is asked. So actually we have a population of 100 individuals and we are interested to know the average income of that population of the country called Gondwana. And they are asking us to sample 25 individuals, and we can be able now to compute the average income from the 25 individuals in order to get the information on the average income of the country Gondwana. So how do you do in Excel when you want to construct a sample based on the simple random sampling method? That's what we are illustrating here. And after you have opened your Excel file, in my own case I've opened it already. So actually you will see here number. You have the variable called number. Those are the number of individuals, and they are ranged from 1, okay, to, if you scroll down, to 100. You see, to 100. So you have all of those individuals, and this is your population. And then you want to construct a sample of 25 individuals from these 100 individuals. And you have another variable that is called province, and you have another variable sex. For instance, individual 1 is from province A and is of the sex, is a male actually, and this is the age of the individual number 1. So that is how this data is designed. Now, Excel has a very good function that have been installed inside that allows you to get a simple random sampling from your population. So how do you do? The procedure is very simple. So you will go and you say equal, you write equal in Excel, say equal, just one equal, and you write a round. This round means random, and is here random. You just double click on that random, and you close bracket. You close bracket. So actually here we are creating 100 random numbers. And these 100 random numbers are the number that we will use in order to determine or to select 25 individuals from the 100 individuals. That's what I was saying there, that we use a table of random number, if you remember, here, in order to construct our sample here. Okay, before using the random number table to select 100 invoice. So that is how we do. So after you have after you put this Excel function equal rand, and then you open and you close bracket, you say enter. You go to enter, you say enter. Actually, what you will have there, one random number will be generated, but I put it on a wrong place. Let me restart it. So actually here we are generating a random number. Let me call the variable random number. And then I will say equal, and I will put the function random, and here it is. I will double click there. Okay, once I double click there, I will also close the bracket and I will say enter. You see, one random number has been generated. Now in our case we need 100 random numbers. So to get 100 random number, you will just scroll down up to the 100 EF individual. You see, 100 random numbers have been generated. So one thing that has to be noted here is that there is a small problem with this function. When you generate 100 random numbers and you want to change something there, you will find that those 100 numbers they can change. You see, if you say okay, you delete one number here, say okay, sorry, let me go back. Okay, let me restart this function because I want to show you, this is very important for you to know on how you can stabilize this 100 random numbers. So I'm deleting this variable and regenerate it again. So I'm saying random, okay, and I will go to equal. I say rand. Here it is. I click on the function and I close bracket and I say enter. So there I will just scroll down quickly, scroll down, and here I have my 100 random numbers. So you will see that if you click somewhere there, you see, so these random numbers they are changing. Okay, so because we don't want them to change, we don't want this random number to change. One thing that we will do is that we will highlight that column and we right click and we say copy. Once we have copied, we will again come at the same place, or we can use the paste function, say paste, and you come here, you take the special paste, you paste the numbers. Once you paste the numbers, you will now find that even though you click here, this number will not change, they will be stable. You see now, the number are stable, they are not changing anymore. So once we have generated this 100 random number, so the following thing that has to be done is to select everything. You select all the variable here, so you can just come here and you just scroll by going to the right, or you can use Control plus A. Okay, there you have selected all the 100 numbers. So there is a different way of selecting this. And once we have selected this, everything, all the variables, now you will go to home. Okay, you go to home and you go to sort and filter. You see there is a sort and filter function here. You just open the function and you will go down to custom sort. Custom sort. You open custom sort and you will have this small box that will pop up. And now they will ask you that, okay, you want to sort by. And you will open this small window and you will say, okay, I want to sort by now random, variable random, the one we have generated here. And everything will remain the same. So you have cell value and smallest to largest. And you will say, okay. So once you click by OK, what you will notice here will be that the number will be selected randomly. Okay. And if now you are interested to construct a sample of 25 individual, so you will just highlight all of this and you scroll down to 25, which will be here 26. Okay, so actually the individual that will be included in your sample will be in the individual number 92, 96, 24, 17, 74, and so on. So these are the people that will be included in your sample of 25 individuals. So that is how, guys, you use Excel in order to construct a simple random sampling. First of all is to generate random numbers, and once you have generated random number, now you will use the function sort and filter, this function here. You click custom, and now you will sort by, random. The variable random was here, and you say okay, and it will automatically select, okay, select or range the individual according to the number of the individual that need to be included in the sample. So what you will do, you will just come here, and take the 25 first numbers, okay, the 25 first numbers, and those will be the 25 individuals that will be part of your sample. So this is the one way on how you do the simple random sampling. So quickly, I want to show you one thing. So I'm deleting this column here. So, and suppose now also you are trying to use or to construct a sample using simple random sampling method, but in Minitab software. So I'm going to Minitab and open Minitab, and everybody has the software already installed on your computer. And here we are with Minitab. As you can look, Minitab looks like Excel. You see here you have a spreadsheet, a worksheet, and here is an output window. Once you do something, if you want, you can tell the software to repeat the result here, and you can see what you are doing. And the software is very easy to use. So there you can file and you do project worksheet. You can edit, okay, clear cells, delete cells, and you can have some function here like data that we will be using soon here. And you have the calculations. You have statistics, basic statistics, regressions, ANOVA. So we'll go through all of these things in the forthcoming chapters. You can do some plotting. So in brief, that is how the software looks like. And guys, this software is very simple to use. So let me explain to you how you import data from Excel to Minitab. So remember here, I still have my Excel spreadsheet opened and I have the data. So one thing that I will do, I will select everything. So I can come here and I select by just dragging toward the right hand side. Here I have selected everything. Or I can do Control plus A. So you just come here, you say Control A, and you will select everything. And now you will right click and you say copy. So here you have copied this and you will remove, close this, and you will just go to Minitab on the column C1 and you will right click again and you say paste cells. Okay, you say paste cells, so you can use Control V. So I click Just a few minutes and here we are. You see, now your data have been imported into Minitab. It's really very simple. You just go your data from Excel, copy and paste, and you come here and you paste your data by doing Control V or right clicking and paste. And you can see that the data will present themselves in the same way that they are in Excel. So actually Minitab is an improved version of Excel, because this one is a computing software. So now we may be also interested to do the same exercise, but one thing to remember here now, because these numbers, they are coming from the data we have generated. So now I'm considering this as my new series, okay, my new sample. So here the numbers don't matter, but I know that I have 100 individual that belong to my sample. You see, I have 100. That is the best important things. And I want guys to also construct a sample of 25 individual using simple random sampling in Minitab. So, and I will call here sample random sampling. I can say _1. So now, one thing that has to be noted here, this first line, okay, in Minitab is the line where you write your variable names. Okay, and one thing in Minitab that you must know is that since this variable number contain numbers, so Minitab will just say that is C1. C1 refer to :1. But look at variable province. Variable province is not a number. It contains letters. And you will see that in the colon C2, there is a dash there, and you have T. T is only saying that you have a text variable. So that is how Minitab works. And once you have a structure of data that looks like this, you need just to understand quickly that this is a text variable, this is a text variable, this is a number. This is why you don't have dash T here, because it's a number and it contains a continuous variable. So now I want to construct a simple a first sample using sample random sampling 1. So this one refer to sample 1. And remember, when we are doing sampling, you can decide to draw your sample with and without replacement. This notion is very important, and you must note this. When you do a sample without replacement, it simply means that if you pick one number in this 100, one individual in this 100 individuals, that person will be kept aside, and you won't take that number of that person and return it in the sample. Once you sample like that without returning the number again in the population, you are doing what we call sampling without a replacement. But if you decide to sample, you take one number, one individual, and you decide again to return back that individual in the same population, then you are doing what we call sampling with a replacement. Pay attention on these two terms, because they may confuse you, and one will ask you to explain what is the difference of doing sampling with and without replacement. So now when you do sampling, you can decide to take a sample of 25 individuals, and then you decide again to do a second sample. So when you do several samples from one population, so you will not accept to have exactly the same individual in your sample number 2 as they are in your sample number 1. Why? It's simply because you are doing sampling with the notion of probability sampling, which lead to the idea of choosing individual randomly. So once you choose people randomly, you won't expect those people to be the same in sample 1 or in sample 2. So now, when you are using Minitab and you want to to sample, so you will go to this function calculum or calculate, and you scroll down, you will see random data, and you will follow that icon to the top where you have sample from column, and you will click on that small window, and a small window like this will pop up. Okay, a small window like this will pop up where you have all your variable on your right hand side here in this small box, and you have the variable number, which contains the number of the 100 individual, the province, you have sex, which is gender variable, the age, and this is the new variable that I will tell the Minitab to put the individual that will be selected to rank them in column number 5. So now here you have this small box that is called number of row to sample. Okay, and the number of row to sample simply means that what is the number of individuals that you want to be part of your sample, and I know my sample must be formed by 25 individuals, so I will put 25 individuals there, and I will come here in this other small box and I will click them, and now in this small box I will ask it that you want to take, actually it's asking me that you want to take this 25 individual from which column, which column. So I know that I want to take them from column 1, because the column 1 contains the variable number, and that variable number is actually my entire population of 100 individuals. So I will click on that one, just to double click, or another way you can just click once and you say select here, you say select, and the variable will put there in this small column, and we are done there. Now you have this other small box where they're asking you want to store the results, store sample in which column. So I want my result to be stored in column 5, this column here, and I have it here, so I will just click on that column, double click there. Okay, and down here you have this small box that you can tick or not. So it's actually asking you that you want to sample with replacement. So if I want to sample with replacement, I will tick. It simply means that if I take one person in the 100, I will again take that person and return the person back in the population of 100. But because I don't want this, okay, so I will not tick it, and I will leave it as it was, as a default. And then I will come here and say okay. Once I click OK, so the software will automatically select 25 individuals from this 100. And if you scroll down here, so it's starting from 1, you can see, and the first person that has been selected is the person number 91, you have 69, and once you come, you will see it will end to the person 25. You see that it's very easy to sample using Minitab. So I can also decide to do sample 2. I go again to calculate random data, sample from column. So I want 25 people, and I'm taking from C1 number, from the variable number that contains the 100 individual. So, and here I will remove because I want to show the result in column C. In column 6, so I will just write C6, okay, and I want to sample without replacement, so I will leave it as it is and I say okay. And here we are, you see, and here I can just write sample random sampling sample number 2. You see, that's what I was saying. When you sample for the second time, you will not expect to have the same individual that have been selected in sample 1. Because you are doing it randomly using the probability sampling, so you may go and collect or select different individuals than what you have selected in sample number 1. So that is how you do sampling in Minitab using sample random sampling. So both approaches are very easy to do. Either you use MATLAB or either you use Excel. So this first part of the video, we will stop it here, and then I will do another video to implement this chapter, and I will post now 2 videos that you will go through in order to understand the entire chapter that we are talking about, how you do sampling and how you can use the central limit theorem to calculate the sampling mean of the sample distribution. So thank you very much, and soon I will post another video that is continuing this chapter. Thank you.